Right, welcome to Bright Engineering. Today we are going to look at some basic electrical circuits and then how to find the various voltage drops across the resistance and the current that flows through the circuit. So with this particular circuit, we are going to utilize the basic things that we already know, which is Ohm's law. So here we are to solve for R and then I in the individual resistor voltage drops, right? So when we are solving for R, when you look at the circuit, R is in series, so we have R1, R2, and then R3. So to find the equivalence of R, see R is going to be the addition of all the threes. So you're going to get R1 plus R2 plus R3, right? And then we are getting R1 to be 10 ohms, R2 to be 20 ohms, and R3 to be 30 ohms. And the addition of this is going to give us 60 ohms, right? So this is the total resistance in the circuit. So let's write that down here. We are going to use it later on in our calculations. And then to solve for our current, which is I, from Ohm's law, we know that voltage is always directly proportional to the current that flows through a circuit, right? And then to get rid of this proportionality sign, it means that we have to introduce the proportionality constant, which is going to be our R in this instance, because the circuit has internal resistance. So to find for the current, we can just make the current the subject, which is I is equal to V on an R. Now from our circuit, you know that V is 12, so we are getting 12 volts here, and then our R is 60, just like we solved, and we are getting this to be 0.2. right? You can just straight away punch it in our calculator and then we get our answer. Now, to the question that we are supposed to solve, the individual resistor voltage drops. We know that for every resistor, because it has an internal resistance, it impedes or it opposes the flow of current through it, and hence it drops the voltage that is applied to the circuit. So for every resistor, we are going to get a voltage drop. But because the resistors are in series, the same amount of current is going to flow through it. So I, which we've gotten here to be 0.2, is going to be the same current that will flow through all these three resistors. And the voltage drop from Ohm's law is going to be V is equal to IR, like we've already used, right? So the voltage drop is going to be the current multiplied by that particular resistance. So for R1, we are going to get the voltage drop, which is V, to be equal to 0.2 times 10. right? And then our answer is going to be 2 volts. For R2, our V is equal to 0.2, which is the current, times 20 ohms. And our answer is going to be 4 volts. And then R2. And then for R3, our V is equal to 0.2 multiplied by 30 ohms. And then our answer is also going to be 6 volts. So now let's test and see if what we've solved for is true. So now we are getting here to be 2 volts, we are getting here to be 4 volts, and then we are getting here to be 6 volts, right? From KCL, we know that the algebraic sum of voltages in a closed loop is equal to 0. So we know the voltage source to be 12, and then we are going to subtract the voltage drop we had here, which is the 2, and then subtract the voltage drop we had here, which is 4, also subtract the voltage drop we have here, which is 6. And then when you sum up all these, we are getting 0 volts, which is true. So thank you very much for watching this video, and then more videos will also be coming. Stay tuned.